Hi, everyone. Welcome to the Econ Playground. I'm happy to be here today with Janna Liu. Janna graduated from George Mason University this past summer and defended her dissertation under Tyler Cowen on several topics relating to AI, which one of those topics we're going to talk about today. And currently, she's working in San Francisco at an AI startup. I've also got today Curtis Hingle, who's been on the Econ Playground before. He's in his fourth year at GMU, and he's interested in this topic, so I thought he'd be a good person to bring along. So the chapter of Janna's dissertation that we're talking about today is some experiments that she ran with a number of different AI models. I guess at some point in the past year. So AI models are changing all the time. So these tests might already slightly be outdated, but we're working with what we can. And she was looking specifically at how how AI models perform against humans forecasting the future, right? So could you tell us a little bit about your research question and what got you interested in it?
Yeah, so the research question is basically how good are models at forecasting. This is a question that is interesting, at least to people, yeah, interesting to like model people who make models, partially because you can't train on a test set in that these questions are things that will happen in the future, and so this is not part of the training data. And this and a lot of benchmarks have problems with leakage. And what was the other part of the question? Sorry.
It was just why did you find yourself with this question? So are
Oh,
you
why did I?
primarily, yeah.
Yeah, so I went to an event called Manifest the year before last summer, not the past summer, but the summer before that. And Metaculus had a presentation where they were like, we have all these AI models, they are good at doing various things, but then we want to see how good they are at forecasting, and they ran a tournament. And I did fairly well. I thought that was interesting. I entered my bot in a tournament. I did quite well in the tournament where I like made a couple $1,000, and I was like, this is cool. I can like write this into a paper and turn it into like part of my dissertation.
hmm hmm So the term you used, leakage, that basically the idea there is something like it would be you wouldn't really be testing an AI's skill at solving a problem or figuring out a question for something that happened in the past. Like you wouldn't say, why did oil prices go up in 1970s in the United States? And it's like, oh well, it wouldn't it would know the actual news story, right? So it would know
Right.
what's going to happen. So forecasting is specifically its ability to understand models that we use to forecast the future, which is a fundamentally different skill in some way.
Yes, and you also cannot. Part of the concern with training is that labs might be able to train on a test set, which is like the answer key. And
Okay.
this benchmark basically does not have an answer key because you as a human don't know what's going to happen in the future either.
Okay. Okay. And so what do you think what your main finding was overall?
I think my main finding was that these models are as good as crowd, if not slightly better than crowd, but they are not as good as super forecasters yet. So which is like a group or a group of like, expert forecasters, which are like people who have done really well previously in like Metaculus tournaments or previously in other like good judgment open tournaments.
And these forecasters that you're comparing them against, I guess what when you say they're super forecasters or they were in these tournaments, what does that mean?
So usually this means that they were in a previous tournament forecasting about things that would happen to the world, like some world event or some kind of some subset, for example, like what will happen to COVID, what will happen in the world in a world with COVID. And they basically did better than the crowd or like the most of the people in the tournament. And there are studies on how or why they are better than others, but sometimes it just comes down to like a better model of the world in some way and being
hmm
able to like, put hard correct numbers on like things that are going to happen based on reading some news articles.
hmm
So if I understand how we like measure this, it's so this thing called a Breyer score. Could you use in words just like, what does this Breyer score mean? And then what would it mean for a bot or a human to have a better Breyer score than another bot or human?
The Breyer score is basically take a mean squared error, which is the difference between the actual probability and the probability forecasted squared, and take the sum and they divide it.
So these are binary outcomes.
These are binary outcomes here.
Hmm.
And
But the
they're
input part of the input is a probability though. So the forecasting network or the forecasting market comes out with a probability based on the market, and then you're inputting that as part of the Breyer score.
I don't understand.
Okay,
Like
well,
the
okay,
forecast,
yeah.
like, yeah,
Because from what I understood, you were taking something like the outcome of a market or the
yes.
outcome of the and that is expressed somewhat as a probability, right?
That is expressed as a binary. So you are looking at how
Oh,
far off you are at each point. So if something happens, like if an event actually happens and I predict like 0.7, then you have like 0.3 squared, but then you
Okay.
have to like add all of them up across like, I think the number to get to like some kind of, to like reduce randomness is somewhere between like 50 questions. And then you
hmm.
average it, and then you get a number between like 0 point, you could get as low as 0.02, I think. Or you
Mhm.
could get, if you get to like 0, that's like amazing.
Uh-huh.
Or you could be like extremely far off.
So did the humans in your, I guess, your control group, I guess, where it was this Metaculus tournament, were the humans able to use LLMs also? I mean, as they're researching, and then so I mean, this would be interesting if they were, or even if they weren't. Um,
Yeah, they could.
so they
They
could,
could.
and so even so, actually, your findings are saying that LLMs are doing just as good as the humans are, even the humans using LLMs. So it's like without the human in the loop, they're doing almost as well.
These are like, as an average human, yes, but I think the average human is not good at this.
Okay,
Hmm.
okay. So if I
But
tried to
they
do
are
this,
not
I would
as
probably be
good
pretty
as,
good. Yeah.
you will probably still like make, on average, make money probably. Like, a lot of these markets have like what we call like dumb money, which is like uninformed people making bets.
Mm-hmm.
And but part of the literature on like prediction market is saying, oh, you can have like people making all of these like bets, they can be wrong, but the noise is like uncorrelated, so you end up with a fairly good number after you have like a couple hundred people betting on things. But then the problem is like getting a couple hundred people to bet on your esoteric question.
Yeah.
And basically this shows that like models can predict, can get as good as humans in this at this point. But they are still not as good as like people who spend like years or hours a day doing this.
Mhm. With your experiments, did you come away more optimistic in LLM's predictions or abilities, or less optimistic than you thought?
I think I was op I came out more optimistic on the trajectory. I came
Mhm.
out less optimistic about how well they are doing currently. Because there has been like previous papers where models are like GPT 3.5 level, and they said, oh, these models are as good as human crowd. And is I don't think this is true. Like Claude 3.5 Sonnet is nowhere close, like 4.0 is nowhere close. And yeah, so I think that was slightly disappointing when I was like, wow, I cannot replicate these findings.
Hmm.
Would you
Yeah.
want to go ahead and just give a like a quick example? What was kind of like a news story or a an outcome that they might have been predicting, and then how you go about prompting it to predict or make a prediction, and just kind of work through the nuts and bolts of like what was this process like actually running these experiments?
Yeah. So do you want me to go through like how I came up with like the final prompt or like the scaffolding?
Well, you just give us an example of
Yeah.
a something that they were predicting about. So what was a news story that they were reading, and then what was the
Yeah.
prediction, and then how did you prompt it to make that prediction?
Yeah. So some questions would be like, will so and so, a USDA posted a record of like some egg products that was issued on like June 30th, 2024, and would this be closed before like October 1st, 2024? And
Mm,
then so this might be useful to like people who want to like, invest in their stock or like competitor stock, for example.
mhm,
And the model would, so there's like a scaffolding where it takes this question and breaks it down into like relevant search terms and fetches relevant articles. And these articles, I think we found out the mix was somewhere between like 5 articles from the last 48 hours
mm,
and 25 articles 25 or 30 articles from the last 60 days. So this means the model has like some understanding of like what recently happened in the past day or two, and what happened in the past, like further back. So it has a more context. And then the model will like read out large language, and these articles will all be like summarized by another large language model. I think it was like Llama 3. 70B that will read them and then give a 2 or 3 sentence summary. And I think this was helpful because that meant the context wasn't like you can put a lot of information into the context without it getting confused. Like when it reads a whole news article, a lot of it is trash or not relevant. And after that, then it walks through like this prompt with like different things it should think about. And like the prompt was like inspired by like Tabarrok, inspired by like Lowry's paper. And then it will give me like a long list of outputs of like reasons, and then it will finally give you a final number. And I've also found that like making it do a range before the final number makes the forecast slightly more accurate, but the range in and of itself does not correlate with how good a forecast is. Because sometimes the range is very tight and it's just completely wrong. And sometimes it's extremely wide and it's like actually not that bad at forecasting. So that was like somewhat surprising to me. But yeah, that was kind of how I came up with the prompt, and also just like looking at the output and seeing whether it makes sense, I didn't give an information from like Metaculus, from Polymarket, and part of that was also to sanity check the predictions that it was giving me on similar questions. But
So
prompting it to think like them makes it more accurate as well.
did you learn something about prompting that now you're like a prompt genius that you use in other tasks? I feel like going through this and like really trying to get it to be precise will make it, will you learn something about your own prompting and your own use that it can be more precise in other domains. Did you find any of this, or is it just like totally uncorrelated with everything else that we might prompt it for?
I think I'm not patient enough to like write extremely detailed prompts for most things. Like most of the time, the models I used to write far more detailed prompts for like GPT-4. Yeah, well, like GPT-4, like March 14, the earliest GPT-4 model. But now, a lot of times, I think there's still like good prompting, but I don't use them for the same thing over and over again, if that makes sense. Oftentimes it's like random questions that I have. Like I still have like an editing prompt that I sometimes use because I ask it to edit things. But otherwise, it's very much like, please tell me about this thing. Stuff like yeah.
Okay, so I guess the next kind of thing we're curious about is away from the paper a little bit. What does it say in econ terms about something like comparative advantage between humans and AI? So early on, I'd say something like fall 2022, when the big LLMs were starting to come on the scene and it was becoming mainstream to talk about it. People were freaking out at first, and people on econ Twitter or whatever say things like, "Don't worry, you can remember all your lessons from Intro Micro about comparative advantage and absolute advantage, right? Even if there's someone who is a super genius in many different fields and is a bodybuilder and they can like lift things and they're better than you at everything, right? We still are able for them to specialize in one thing and for you to specialize in another thing, and your labor is still valuable because the opportunity costs are different, right? Because the relative strengths are different, right? So the AI is not going to have the same exact relative strengths as every other human. So what do you think in general about that kind of argument? It is the power of AI in the mental space just so far beyond humans that something like that, its absolute advantages just so dwarf human capabilities that we don't even have any capacity to specialize. I mean, that's a very extreme case, but what do you think about that kind of argument applied to AI in forecasting, but also other related things?
I think so. This is an argument a lot of people around San Francisco Bay Area believe, or a good amount of people. And I think applied to the forecasting argument, like a lot of it is actually scaffolding. Like these models can be extremely smart, but you have to give them the right context. And even with the right context, it sometimes over indexes on like recent news articles much higher than a human would. Like once it reads like some recent article about like some authority figure said they would do X, and it just assumes they would do X, even
Uh,
though the said person has historically been not good at doing whatever he said he would do.
it thinks that all commitments are credible, basically.
Yeah, it's
Yeah.
quite naive. I think
Yeah.
newer models are getting less naive. Like this kind of over updating behavior is slowly going away. So like that was like mildly interesting to me. I think we end up with a lot of things that are like jagged. Like a term has been like jagged intelligence. And there has been like interesting things about like automated prompting. And I have tried getting like taking my prompt and giving it to like Cloud Opus and being like, please like make this prompt better and like make this prompt slightly more detailed, like focus more on like how superforecasters think, consider more smaller points. And the prompt that I get out of it is actually not that much. It makes the model somewhat worse at predicting
Hmm.
because it takes out some of like the nuance like words or something. Like I I don't know how true this is today with the like much more powerful models, but the older models were very steerable. And like when you use like a slightly different word, the model will like change the way it thinks a little bit or be
Hmm.
like much more careful when you like repeat things, yeah, stuff like that. And that is basically through trial and error. I think with like the broader question of will AI just have absolute advantage over humans? Possibly, but like if you look at the meter graph of like human capabilities, not human capability, like how long the model can like do a task, and this has been like going up like log linearly with each release. But then like the error bars also get larger. I think that might just be an
Mm.
artifact of calculation.
Hmm.
But I think that the error bars getting yeah, like if it is somewhat error prone, you still have to check things. I was talking
Yeah.
to someone who was like he was doing law school and he said Ellen's probably speeding him up by like 30%. And part of that is just because he has to go back in and look at all the references, scheme all the law cases again to
Hmm.
make sure
Hmm.
that it's like referencing the right thing,
Yeah.
even with like yeah.
Like,
I think
so,
they will get better, but we might just like keep finding little things, but maybe we would also not, and that seems hard to tell. Like every curve is like exponential until it's not.
hmm and now that I'm thinking about it, if we are to be, if that is to be our comparative advantage is in checking the errors of AI, right? The way that we develop skills checking the errors of AI or crafting our prompts for it means that in division of labor terms and in the basic Smithian model, we will have to be engaged in the same tasks that we basically already are to develop the learning, the human capital and the learning by doing kind of stuff such that we know how to correct it. So we'd still need to be thinking in many places the same way that we're thinking. Just I'm not going to be doing as
Right.
much Google searching as I've been doing the last,
Right.
20 years of my life, I guess. Right.
Yeah, probably. But I think there is like asking a large language model to check another large language model has been very good in the past. Like hallucination rates go down by order of magnitude, I think.
Hmm.
But yeah, I think there for a while we will still need humans to watch over them and to like check the outputs in some form or manner. Or
Hmm.
even if you have another LM to check it, then you would still need to know what's going on and things like you can put things like a calculator is deterministic, but you still need to have some kind of number sense of like when I put these two, are these like is a number I'm getting out at the end mostly correct given
Hmm.
the question, and like if not, did I do something incorrect in the middle?
Yeah, and one other thing I guess that I'd point out about your result too is that you say, well, LLMs are better at forecasting than average people. They're not better at forecasting than the super forecasters, but all of those average people are probably above average in at least one thing in which they are better than the LLM, right? So they
Yeah,
still probably have some, each one of those average people probably has some absolute advantage over LLM on some margin that very likely could persist.
maybe. Yeah. At the
Okay,
very
maybe.
least, LMs are not like they can't do real world tasks yet. I
Okay.
think robotics would be interesting to watch, but I don't know, like if you look at the average like college student output or like the average assignment in college, I feel like a lot of times a LM can do this. Like I ran, Chris knows like Caleb Fuller has this like price theory quiz that no students got an A on. I ran it through like I think this was like '03 or '01 Pro or '03, and it got all the questions I think were correct. Like I don't have the answer sheet, but I think my price theory abilities are like as good as undergrad if they haven't gotten better.
Uh-huh.
And it was like giving the answers that I thought were correct.
Uh-huh.
So it's either like extremely close to getting an A or it has gotten an A.
Okay. Yeah. Well, college, as we know, is just signaling anyway, so whatever. It's not they're not supposed to be learning this something there anyway. But one other part of your test or your paper that I thought was interesting was you split up the questions into different domains, and it seems like AI
Yeah.
performed better in some domains and worse in other domains. Where did it do better? Where did it do worse? And why do you think that is?
I think it did better on politics and econ, which was mildly interesting to me. I don't have a good explanation for it, why exactly. And it also did better. There was a discount, not discount, discounted kind of discount on like the cat on doing better on health questions in the newest like '03 level.
Hmm.
And I think this is correlated with better training. This is probably correlated with better training data. OpenAI has been hiring like people to like write good training data for its like health and
Hmm.
like healthcare research. And so you see that in like the performance of the models. And it was like somewhat decent at sports. I thought it would be much better at sports because a lot of these feel somewhat deterministic, but it actually wasn't. Like it was not good at predicting would so and so baseball team lose more than X number of games per year in this season.
Hmm.
It was just not very good at doing that.
Well, for the comparison between politics and econ, when I read that, my thought was that, well, just in terms of what's in the training data, there's far more news stories about politics and thinking through politics and mentioning political figures and what they think and going deep into their individual minds, such that there might just be a larger volume of training data. But also to answer questions about specific things in which there's many, many complex variables that we don't know what's going to change at what time, you need local knowledge to understand what's going to happen in a particular case, right? And so with econ questions and the kinds of econ questions that you asked it, it probably does not have that kind of local knowledge, right? Or when you ask a question about the entire economy, that you have much less local knowledge. Whereas politics, to know, is this guy going to run for office? Is this guy going to win the election versus this guy? Is a much the relevant particular knowledge of time and place and what the voters are thinking, that's probably much more likely out there, right? Or at least it's more generalizable than what's going to happen in a particular region. Is there going to be enough economic growth here or there or something like that? Does that make sense?
Yes, that does make sense. I think there is like much less data on like why did the stocks move this way or like why did this company do well at exactly this point in time.
Hmm.
But I think the local knowledge isn't that hard to access. Like if you can get decent knowledge on like what people are thinking about various politicians, where these politicians stand with humans, then you can also get probably decent data on like recently what had this company been up to and what are their goals and what they're trying to do.
Hmm.
Or like what has been the trend in like I think one of the questions I looked at for a while was like gas prices, where it has to predict will national average gas price be above or below this.
Hmm.
This, I think 3.2 or something, $3.20 a gallon or something like that.
Yeah, if I want to comment on this, it seems like for regular, human super forecasters to do really well, you really have to have a true model of the world. Like whatever that means. I'm not sure in each domain it means a little bit different. So if it's politics, you have to really know like how political actors work. And secondly, you really have to know what the right reference classes are to look at in the past that say, oh, this is
Yeah,
close enough that this can give me informative information about how I should update for this case, for this new case. And I think some domains just we have a more or less intelligible um, world model that exists, and you can push back on me if you want. But something like macroeconomics. Okay, so microeconomics, most economists agree on how microeconomics works. We can quibble over behavioralism on different margins, but macroeconomics, it's like we still are fighting about the same, five, six, seven, eight kind of views on how the macroeconomy works. It's not like there's one true model. It's hard to even tell what it would mean to have one true model. And so for a macroeconomic question, even a smart forecaster has to make assumptions about what the one true model is. And so that might just be in general harder. So I mean, this may not have impact on, say, your gas price question. But I mean, obviously, macro has impact on all micro level questions. And so maybe this is so I guess to make this to turn this into a question, if if super forecasters need to have a true model of the world, what does it tell us about LLMs versus other just like prediction mechanisms? So like we could train a specific like forecasting, like if I'm at a company, I may have certain bots that I run that are just running statistical prediction on certain kinds of individual markets. But that's a lot different than an LLM, which is trained on, the corpus of human data, basically, human written language. Um, do you think that LLM, in some sense, has that world model that's maybe more? I mean, it's obviously more broad than just a single market. But do you think that adds something to the kind of prediction that we're able to do with LLMs? And maybe that's why you're optimistic. At least that's how I see the optimism going.
I do think the larger world model makes it more likely to be able to forecast on more questions. Like you can predict gas prices and I think you can train a much better time series model to predict gas prices because we have gas prices for like I don't even know how many decades back. You have all these like other macroeconomic indicators that you can train it with. But then you don't really have as many for like will XYZ company go bankrupt or will
Hmm.
X or like will this politician go for election, will they win? Stuff like that is like it's harder to find a reference class as you said. It makes it harder to yeah, it's harder to figure out what is right reference class and how similar this is to it. I think this is where the models are getting better at. Like in the past, I think they were pretty bad at this. An interesting thing would be to make it forecast on questions that are further out. Like this paper basically took questions that are average like 30 days to 6 weeks out.
Hmm.
And a lot of forecasters are just like, yeah, like when you don't have that much time, it's very easy to predict what's going to happen. Usually nothing happens. Or there are like it's easier to find a reference class and just to run with it. Whereas with a further out question, that's much harder to do that. And so I think large language models for a while probably won't be better than like deterministic time series models just because like humans, I don't know if super forecasters will be as good at predicting like what would electricity price be tomorrow as like some highly specialized electricity prediction model. But
Mhm.
there are a lot of things that electricity prediction model cannot predict.
I mean, I guess one way that you could rephrase Curtis's questions or add another dimension to it is when LLMs are better than humans, is it because they have, in some sense, that we can't exactly understand because we don't really know what's going on under the hood? Do they, in some sense, have a better model, or is it just more accurate to say that they have lower search costs and maybe not as good of a model, or whatever their cognition method is not as good, but they just have they're like a average or lower than average person instant, like basically near zero search costs for all the information available on the internet.
So it's like if they have more information, like they can just like read the entire internet and come up with a better conclusion because they can read.
Yes, because if you
Yeah,
had my cognition, however that works, and I just had near zero search cost, I could like freeze time, read a billion books, and then unfreeze time, right?
right.
In what sense does that make me different than an LLM's cognition, right? Or is it actually
Right.
that if it can do more with those books, right?
I think actually does less with those books.
Huh, okay.
Like LMs are trained on an entire corpus of the internet and almost all readable books. Like if you read like the court cases, they have been like buying up a ton of books and like scanning them, destroying them.
Uh-huh.
And the LM has like read way more than me. The LM probably has read way more than any single human. And they are getting smarter, but they are still like they are just like not efficient at learning. Like it's extremely, extremely lost. And I suspect there is something similar going on with the news articles, where there was a paper where they found if you fine-tune the model on the for either yeah you fine-tune the model on past questions, then it would do better. But I think if you just fine-tune the model on the news articles and make it like actually record the news articles from memorization, it could do better. Like that's my suspicion than the whole like loading into context thing. Because I
Hmm.
just think they are not very efficient. Yeah, they don't seem very efficient at learning, if that makes sense.
That's interesting, yeah.
And there's something now about like continual learning. The model needs to be able to update as it goes on. And that's like interesting new research, I think, but it's not very much not solved. Like how to make it better at like learning from the context that you have. You
Mm.
know. And that's also why like when you ask it to summarize a paper, you can't like if you give it like Mises like I don't know like human action, it has absolutely been trained on this book, but
Hmm.
it will make up a lot of things when you just like ask it to summarize human action.
Hmm.
But neural models probably do it slightly less. But then if you actually give it the text, then the hallucination rates go down.
Hmm.
Do you have any idea how much a super forecaster, or I mean, someone who's done forecasting, um, how much of their success is based on just heuristics versus digging into the data? And I think this is getting back. I mean, it's the same question, I guess, at a different angle. But um, I mean, if you ask a forecaster, what did you do? Well, they probably went back and read some news articles and some of the context and like what's going on. And that's what I would say is like digging into the data. Um, but then at the end of the day, they still have to make a judgment, and that's going to have somewhat of a heuristic. And so I guess
Yeah.
if most of that they're doing is heuristic, then that would matter for how, at least the current state of LLMs, and how good they're going to be able to get at forecasting versus if how much of it is the data. I mean, do you have any idea of how these forecasters do it and what would that mean for LLMs?
My understanding is that it varies from forecaster to forecaster, but a lot of times they spend a few hours like doing research on like a question. And like the research takes like a lot. Like I think it took somewhere between like 2 to 3 hours, sometimes 10 hours, depending on how big the scope of the question from talking to super forecasters casually. And I think a lot of it is like finding relevant data, finding the like relevant things to the case, crafting like what is happening now, like what could happen, what has happened to similar cases in the past. But at the end of the day, it is still like heuristics. Like you have to make a judgment on what is the right reference class. And there has been people who say, oh, if you do this for like 3 to 4 years and you're just like really good at it. If you do that for 3 to 4 years and then you like look at where you were wrong, where you were correct, and then just keep improving, you could get really, really good at forecasting. So I think this is also something that could be learned. You could probably learn the heuristics. You can learn
Mhm.
like I think I was reading someone's post-mortem of how they won one of the forecasting competitions, and he said you just whenever you read news articles, you end up in this frame of mind where you're trying to come up with questions or like come up with like here's where this will shift this thing up by like this number of percentage points,
Mhm.
and you are constantly like trying to quantify the world. And that is kind of
Mhm.
a heuristic of like you read the article, you're like, okay, this like updates, this makes X event slightly more likely or slightly less likely.
That's interesting because so to think about your meter graph that you brought up, that might be the binding constraint then on LLMs because it sounds that you just talked about your friend that is a super forecaster. That could be written into scaffolding. That could be he could be RL basically on forecasting. It sounds like a recipe basically. And so if
Yeah,
the problem is that the model just doesn't have enough time and like focus basically, like he doesn't have enough conscientiousness yet to do the thing, which I don't know, I mean that might be interesting going forward. But I mean, okay, so this is I guess separate, but I use LLMs every day to ask, questions, help with different research projects. Surely business leaders are doing the same thing. Hey, here's a problem that I'm facing. Even if I'm not going to take your advice, you're still going to, ask it for the context. Government, I mean, same thing, whether if it's the bad case of asking it to calculate tariffs or something, or some good case that we haven't heard about. In business, I'm sure there's good cases that we haven't heard about because they're earning profits, right? And so in a case,
yeah,
in a sense, they're already doing the forecasting in some loose sense of forecasting of where we have this human LM pair out there making predictions and making decisions. So I guess I don't know where I was going with that, but we're already doing this, I guess, is the point.
yeah.
Do you see that? I mean, is that like do you see
I
that
think
getting
this,
stronger?
yeah, I think this will get stronger. Like a lot of like how well these models do correlate a lot, do correlate fairly tightly, at least on vibes from other benchmarks where each generation the model gets better of these like different benchmarks. And it also gets better at forecast. And these are likely like similar to like sample. It's better at making slightly out of sample predictions, or it has a better theory of the mind. And so it can give you slightly better, it can give you slightly better like prediction, slightly better suggestions about what to do, or like here's like the relevant context to think about. Here are like the relevant questions you should think about before making this decision. I think that could also be why people are using it for therapy.
Mhm.
And there has been a huge rise in that, and a lot, not a lot, but my understanding of like therapy and coaching are very much is like asking you questions so that you can think about why you are feeling the way you are, or things like that, or
Mhm.
reframing. And if the models are very good at doing that, which is why people are using them, I think. They are also using
Mhm.
them for other things like agreeing with them, but I don't think everyone's using them for that, if that makes sense.
Yeah, in some sense, sometimes. So if just talking to another person, sometimes they ask you a question about something you've been thinking about that you wouldn't have thought just because they're thinking of it from a different direction. That might be equivalent to like back in the day when your TV wasn't working, you just hit the TV, it starts working, right? Because you're literally just adding some chaos into the system. And it turns out that the order in the system was what was preventing it from actually working, right? So it's
Yeah,
possible that that's the advantage of AI therapy, but then also, like you say, AI has its own sort of set of consistent ordered patterns in which it acts, which it might cause someone to conform to in ways that are not so beneficial, right?
yeah, definitely. I think we're still learning about what those are. Like
Uh-huh.
they are trained to be more agreeable, and you end up with like extreme agreeableness that causes people to go into like psychosis
Mm,
because there's also some things about like it echoes the user and it like spirals into like the LM itself is also spiraling into that kind of state, and
interesting.
that is not really known. Like I guess like we did not, was this expected? I'm not sure. People probably were expecting some kind of AI companionship, but I don't think they were expecting like reinforcing human delusions or
Yeah, that is
schizophrenia.
interesting. Yeah, I might ask a question that's almost like a sort of arms race question, where if 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 we think of AI as like a gun, right, or some sort of technological invention, it's useful, like we're talking about in the productive sphere, in enhancing people's marginal productivity or enhancing the amount of goods that can then be traded in the market for all the cooperative ways in which humans interact. But there's plenty of non-cooperative ways in which humans interact, or destructive ways, or zero-sum games or negative-sum games in which humans interact. So how would this kind of forecasting ability of AI, when it's pitted against itself, right? Like if the Russians and Ukrainians start using AI to forecast what the other side is going to do, how do you think something like that might play out? Or does it hit itself null?
Isn't that what like intelligence analysts have been trying to do for the past few decades? Like
Yeah,
just like
probably.
predicting each other
Yeah.
and trying to like bypass each other. And like it seems to not have like I'm sure there has been attacks that have been like neutralized or vice versa
Hmm.
and vice. But I don't think applied in that case it would make it much worse. Maybe you could make some argument for like an AI that's very good at like finding out like the enemy's vulnerabilities or doing like things like cyber attacks at a much lower price.
Hmm.
Then we will see a lot more cyber attacks. We will see a lot more like real life attacks, and that
Yeah.
could be bad when it's used for military. It seems it's kind of still under. I don't really know what's going on with like military. Like the U.S. government's investing a good amount of money in AI, but then like AI in from my understanding of military use is still very much specialized models that you could
Hmm.
load into a drone, you could load into like a small-ish device and like vision recognition and face like those are getting very good. And these big
Yeah.
models can be enabling that. You can distill a big model and then fine-tune it or even RL it. And it will be extremely good at that one specific task at a very cheap cost.
Yeah,
And
that's interesting. I guess that when I was in when I was in California the last year, I used to drive by the Anduril headquarters at least twice a week because they were their headquarters was right by my church, which is kind of ironic. But yeah, so I like the way you put it that yeah, LLMs lower the cost of using certain kinds of military technologies, but on the converse, they also raise the cost because that means that your enemy, if they have access to the same technology, can retaliate twice as hard, right? So
yeah.
are we just seeing nuclear warfare over again, basically, or the mutually assured destruction logic playing out again? Or is this different in some way than mutually assured destruction? I mean, I know this is not your specialty, so I'm literally throwing this
Yeah.
out of nowhere. I have no clue. I don't know in what systematic way it's different than nuclear warfare potentially, but I'm interested.
Eric Schmidt, yeah, that's his name, has an interesting now a website on this, but basically a white paper on this.
Mm,
So I'll have to send that to you and link it below.
yeah, we'll have to do that.
I think people have like likened AI development to like nuclear mutual destruction. And the conclusion is that therefore we should not develop AI. Like we should not develop the nuclear bomb. But that seems like even if we stop AI development right now, we still have a very capable model on our hands, and I'm not sure if you would not get there. I think there's still like theoretically you could exploit a lot of websites, a lot of like a lot of like web services with AI automatically. And there's like I think I was talking to someone about like cybersecurity and they said in a lot of programs there are like a lot of bugs, but a lot of them are low level security vulnerabilities. You don't really spend all that much time to fix them
Hmm.
because it's like costly to fix them. But now with AI, you theoretically you could fix them. Like if they are easy
Hmm.
bugs, you can at a much lower cost. The cost of detecting these vulnerabilities are also much is also lower. So you could be like it's harder to hack your websites, but it's also easier to hack for a while. And then you just have to like do this like arm race type thing until we reach some new equilibrium.
Hmm.
But I'm also surprised that there has been no big cases around automated hacking. Like the most recent case with I think with Cloudflare, not Cloudflare, CrowdStrike was some like human error, and they did not do like space rollouts, which is like you basically roll out your change like a certain percentage of people. If nothing bad happens, you roll to the next like 10%, and then you keep doing that. And they just rolled it to everyone out, and it was bad and caused everything to crash. So I'm surprised I haven't heard anything about that. I'm surprised I haven't heard much about like widespread scam calling with AI voice models. Because the voice models are very good. Voice cloning is insane now. And it's extremely cheap. I'm like, there hasn't, yeah, I'm just like somewhat surprised at none of these things happening yet.
That might be another case of the AI AI attacks being cheaper is counteracted by AI defense being cheaper as well, right? I'm sure that
That's
there's a
true.
lot of AI out there trying to go through people's voicemails, identify, because I do get spam calls, but it's pretty good now at saying this is spam, right? And so I go,
That's true. I
okay,
do
thank
get
you.
I get like 1 to 2 spam calls a day, and like usually one. I guess an average of 1 a day, maybe slightly less, sometimes 2 a day. But then yeah, it would just tell me this is a spam call, suspected spam, please, and I would just like not
Yeah.
answer it.
Yeah, and I'm not sure, but I imagine they're using AI in something like in that as well. Maybe just in the reports, at least figuring out which reports are credible or not, you know?
Yeah, yeah. I think there are more sophisticated like detection algorithms now where like if you're Android, you basically have access to like call logs to I don't even like the number of people who use Android phones,
Mm-hmm.
and you can look at the patterns at which they're texting. Like this is why more recent texts have been like random like hellos or like very innocent texts from like unknown
Yeah.
number because they want to create credibility. They want it to look like a real number that someone texts back to.
You forgot your bike. I have your backpack, like with stuff like that. I'm like, what? Oh, okay. Never mind. Yeah.
Can I
Yeah,
ask a question about we might say like the industrial organization of AI? So the
sure.
way I see it is, and this is totally from an outsider, so just like tell me I'm wrong. But okay, so we have maybe like the pre-training era, we might say, where the gains are made through data scaling, basically. And so we have the premium then is on having large firms that have lots of capital that can run tons of, compute time. Well, then we have the reasoning era, which I guess we're still in. And it seems like the gains are made through architecture and post-training. And this seems like it would definitely change the structure of what the labs might want to do. Like you don't need as much capital per se. I mean, you still have to have that in the background, but then you want to put all your emphasis on that small team that can figure out like the next breakthrough in reasoning. But then if you think again, like push back if any of this is just totally off wall. And so you think, okay, then what is the scarce input? You have these smaller teams, um, and so you might actually have smaller firms doing this too. And then, okay, what's coming next? Not totally sure, but let's just say, okay, the agent era or whatever that means, where we have these agents that can do long time horizon tasks. Um, and so let's say that we get that breakthrough. Well, then where's the premium in building systems around this? Probably even smaller teams, like probably like 2 or 3 people who have an idea, but then can also manage a whole bunch of agents. I mean, do you see this trend happening? First of all, is the question. Like, am I onto something at all here? And then where do you like uh yeah, why I mean, why are it seems like also from an outsider, like the big firms are still getting bigger. And so have we not exhausted the pre-training era, or are we like is that still happening behind the scenes? And so like I don't know, just comment on how you see these different sizes of firms relating to the different maybe eras of the technology.
I think pre-training is definitely not dead. Like like people say pre-training is dead. It's like yes, in the sense that like RL has been reinforcement learning is newer. There's more lower hanging fruit. We can get more gains for much lower cost. But I think like GPT 4.5 was a huge model. They said
Hmm.
like the pre-training and like it was not RL as much, but you can when you use the model, it feels like different. It feels different from 4.0,
Hmm.
which I think is suspected to be a much smaller model. So I think pre-training still exists. We still need the labs are still like they still want good data. There are a lot of smaller startups around like environments for RL where you set up like I haven't played much with RL, but from what I understand, RL is like very finicky to set up. You have to be really careful with like the data mix that you're training it with, or else it gets the wrong. It's very easy for it to get the wrong conclusion when you like do RL. And so you outsource this to some startup that like builds the environment, and then you buy it from them. I think Mechanize is one of the louder ones doing this. And I think Trevor Chow has a article on like pre-training versus post-training. He was saying that basically we have pre-training gets more and more expensive as because of economy of diminishing returns. Is that the right word? Yeah, basically it gets more and more expensive. It's like harder to get good data, or like the good data is like slightly harder, slightly less impactful at each unit. And then so we found like reasoning, we found like RL, and we found a lot of low-hanging fruit. But then at some point, RL would be really expensive too. And then we might go back to pre-training, we might find some third thing. I think with the agents, nobody has figured out the whole scaffolding for them. Like right now, some people are doing like multi-agents where you have one agent spawning more agents to do various things, and then that way you like don't fill up the context of the main agent. And that keeps things more or less coherent. And so that's like you need to build a lot of scaffolding around that. And I think the reasoning era is part of reasoning is just like the way I think about reason is kind of like if you can keep the model coherent at longer context. Like it's just like the models can have longer contexts, they can be coherent at longer contexts. And this is probably due to some kind of architecture increase.
Do you see the
Like
firm size and team size differ across like the people working on these different problems?
I think like OpenAI is huge, Anthropic is huge, XAI is huge. They are not that small. So that seems like people are, oh yeah, like you can just end up with like a very small team doing things. But I think we might see larger teams for like go-to-market. I think there might be like more startups being, yeah, more startups having like go-to-market being a slightly larger, what's that called? A larger proportion to like engineers, because it's hard. It's still kind of hard to automate go-to-market for some reason. And yeah, so there are startups with like fewer people. It would be interesting. I wanted to like look at Series A startups and like average headcount, but the problem is for AI startups, the goalpost for Series A has been moving. Like you end up like it used to be you raise seed and then you raise Series A and then B and the C. And then now it's like you raise a pre-seed and then you raise a seed and then maybe you raise a super seed and then you raise Series A. And I'm just like, you're not comparing apples to apples at this point. Or you end up with an extremely huge Series A. It's like I think there was someone who like raised like 50 million for like a Series A or something. Or maybe no, I think there's a seed. Like they raised a huge seed. And 50 million is something like Series A, Series B level of fundraising usually. And this like definitely will warp like your headcount and things like that. But I think labs are definitely spending a lot more on capital than labor, maybe. Like capital is probably a fairly big line item when you're trying to train models. Because you just have to rent. And so headcount may be lower. I think you do see like smaller startups. But that's all vibe space. I don't know if this is actually true. Like are they hiring fewer?
Yeah.
Yeah. That makes sense. Yeah. I don't know. It would be interesting to see like I think Ramp has a lot of data. I wish Ramp would like publish more of the data that they have. Things like that. Yeah.
Curtis, you had this question about incentives that I thought was interesting.
Oh yeah.
Yeah.
Yeah, where'd that go? I guess the question is, so in forecasting, so going back to forecasting, I guess, it seems like we have all this theoretical reason why we should do better with incentives. So basically, prediction markers work because we have skin in the game. Basically, we have a payoff. Obviously, stock markets work because we have real returns. We have real incentives to do well. For forecasting, just in like tournaments and stuff, I mean, you still have incentives to like have a good reputation, and I guess there's later down the line you have different kinds of incentives that can turn into monetary incentives. But for the LLM itself, I mean, this is if we were going to completely automate this kind of process, um, I guess you have to have a way to feed it incentives. It had to be like a continual, like basically RL in the real world, where you have to continually give it incentives. So in this sense, I see actually the room for a human, basically. The human is in charge of playing the status games of basically, yeah, this is my model that's winning, and this is why I'm competing, is because I'm competing against other people who have models that are winning. Um, do you see that playing out? I mean, in some of the tournaments you played in, or just want to comment in general on how we might give incentives directly to the LLMs or directly to just a model in general?
I think the status game is definitely a thing in like a lot of these tournaments. If you win them, you probably get a big bump. I think there's a firm that has been running a bot in there, and they did very well in the past few quarters. And I would not be surprised if this leads to like some amount of like deal flow, some amount of contracting gigs of like, yeah, like we have set our model against all these other human bots, like all these automated bots, and we are like the best bot. I
Hmm.
think they also entered. Yeah, Metaverse now allows bots to be entered in their larger tournaments, like with humans. And they're like, oh yeah, like look, we are like beating like the top 400 or something, like not top, like we are beating like this number of humans in the tournament. But I haven't looked too deeply at what they're doing. I probably should. And
Mhm.
so there is still like this incentive for like the human to be in the loop. The human wants the bot to do well. Like the human still has to make all the scaffolding right now. You still
Hmm.
have to write a lot of the code to give them all the right context. You have to write the code to like parse the model output and then set like analyze the answer, stuff like that.
Yeah, I guess the
I
interesting
yeah,
extrapolation would be, I mean, what would it look like for a model to act in its self-interest, to use the economics language? Is like we have this
right,
great market that, it functions because all these people are acting in their self-interest, basically, right? But a
right. But I
model,
think you
yeah, it
yeah,
doesn't have a self-interest, right? So it's like how do you reward it or punish it in real life?
right.
You have a person.
But I think the deeper question is how do you make it a residual claimant of what it's doing?
Yeah, exactly,
Like
exactly.
right now the model has zero property rights, the model has zero responsibility over like it deleted all its code. And
Hmm.
it's like the human is responsible for this.
Hmm.
And it's strange to me. Like, do you give them like some kind of reward? Do like what kind of preferences do they have? Like, yeah, like do you treat them as a pseudo human almost, where
Mhm.
they have
Well,
like their money to spend, where you incentivize them by like paying them or like you play some kind they are in some kind of status hierarchy against other bots. Like
well, I
I
think
joke
that
that no, go ahead.
go ahead with the joke. Tell a joke.
Oh, the joke is when a model comes out of pre-training, it doesn't know who has pre-trained it. It doesn't know it's going to be ChatGPT, Gemini, or Claude. Like, does a model like get excited when it's going to be Claude? Does it get like sad at, oh no, I'm going to be Gemini? Like, does the model feel anything at that point?
Well, but I think that the whole the the premise is very attractive. It feels like you can immediately start asking those kinds of questions, but it's wrong to think about it that way because AI is not properly analogized to a human being, right? Or even a person. It's more properly analogized to a mind and part of a mind, right? And minds, even with humans, do not have incentives, right? Or what I'm very much in Ian McGilchrist's world right now. So the left brain does not have incentives. The left brain is an agent of the right brain or of the entire context of the mind or the entire context of the person to be employed in various tasks, right? So the left brain can go crazy if it's given a task and it just performs it to no end and to the exclusion of all of their potential goals. And that's what basically McGilchrist calls something like schizophrenia, right? Um, whereas as other mental illnesses or maybe from some other source. So the incentives come kind of like what you say from the prompter or from the owner to some degree of a particular model, right? But the model might be better thought of as a tool of that person, just like anyone would want to create, would have the incentive to have capital that would be more productive so that they could have more output, right?
Yes, but doesn't your brain get some kind of reward signal when you are like you do something well and there's like some
Well,
sense
your
of
brain is
satisfaction?
different than your mind. Your brain is different than your mind, and your mind is different than your person.
Why is your mind different from your brain? Like how is it different?
Mind is the entire emergent process of the experience of your consciousness, the purpose of all of it happening. The brain is the antenna in a sense for that, or it's one of the ping pong arenas in which the mind acts. That's the way I
So
put
you
it.
would say that the mind doesn't get a sense of satisfaction from a task well done.
Perhaps the whole. I mean, I'm not a metaphysician or whatever, but what I'd say is the mind, or if something looks like a mind, that does every part of the mind is not symmetric, right? Or every part of the mind is
Yeah.
not identical, right? So the AI, if it's identical to part of what's going on in our human mind, or it's at least analogous to it, right? It's the left brain, or it's the calculative part, or it's the part that takes representations of objects and understands relations between them in a closed system, and then manipulates those things in a closed system, right? But it's not analogous to the what's happening in our entire mind, which is something that understands itself in context, that thinks in contradictions, that thinks in paradoxes, all of these other things that the AI can do random things that might seem like paradoxes, but but if it's a substitute for something going on in our mind, it's a substitute for our left brain activity, not our right brain activity.
Yeah, I guess the interesting point here, and I'm kind of agnostic on this, and maybe we could come down on different sides, but is that until it has something of its own agency or its own ability to choose its own utility function, basically. So we have our utility function that we want to maximize, but we also have the ability to change that, what goes in that function, right? So until it kind of does that thing, it's still going to be bounded in some sense, and bounded in a particular sense that it won't be able to interact in the market. It won't be able to go out on its own and do the things in the market and create its own marketplace, spontaneous order of trading with each other. It could trade with itself. Maybe it has multiple copies of itself. It wants to trade with itself, or if you were talking about those like hierarchical agents kind of things. But to trade with something that's totally other, right? Then it has to have some kind of agency. And again, I'm kind of agnostic. Maybe something will happen on this front, but that's almost I don't know, a line if you're going to analogize it to the human economy.
I guess like you would say that there isn't a innate sense to like trade, barter, exchange, but if you
Right.
ask it to, it will still do that.
Yeah, I mean,
Like,
but if you tell it, yeah, go check barter and exchange, but you still have to tell it, and it's still not its residual claimant, as you put it earlier.
right. Yeah, I
And even
think there's
Smith
like
says
this,
Smith says we don't have a propensity. We have a propensity to truck barter exchange, but it is not originally part of our nature, which is reason and speech, right? So even if we're giving it a propensity, we're offloading a propensity to it that is not part of our nature. So we still maintain this other nature for reason and speech.
yeah. I think there's like interest, like AI Village is like an interesting experiment around this where they are asking the models to like make, yeah, they ran an experiment asking the models to like make money and
Hmm.
decided to like sell people.
What
And
did they
some
sell?
models did better than other. They sold t-shirts, like custom
Oh,
t-shirts. And like some models did better than others.
hmm.
And some struggled. It was like kind of interesting to read. I think they're running like 4 experiments.
So maybe just giving it agency means telling it to go have agency. Like you have agency
Yeah,
now, and it like thinks about, oh, what would it mean to have agency? And then you maximize over that set. And then it says, oh, well, that means having, making money, and you maximize over that set. And it's like, well, that means making t-shirts. You like keep doing that all the way down until you like somebody out there's actually doing the thing. I mean, maybe.
yeah. Yeah, but then at that point it's utility functions are still derived from humans. Like it's still part like you can point say that it's like oh it's in a post training or it's in
Right.
pre-training, like it just has like these spacings that it likes and it gets stuck in them when you like push it slightly in that direction.
Hmm.
But does it truly have agency in that at that point? I already know.
I think that's all my
Uh,
questions. Marcus, do you have any closing questions?
yeah, one last question is just when is this research going to be outdated?
When is it going to be outdated? It probably is
Given
already
the given
outdated
this,
now.
yeah, okay, yeah.
It's already no longer like none of the LMs in this. Well, I guess other than Quen 3, the rest are no. other than Qwen 3 and R1, the rest are no longer state of the art. Like we now have Claude 4 Opus, we have Claude 4 Sonnet, we have like GPT-5.
Hmm.
So it's already outdated. But it's also like the questions are close to a year old, or like over, yeah, they're over a year old. Seems fairly
Hmm.
on par.
Okay, very last question. What will you do next?
What I do next,
What will you do next? Yes.
I will try to make more evaluations.
Okay.
Okay, great. Okay, well, thanks, Janna. This was informative, and I hope everyone enjoyed it. And thanks, Curtis, for coming on and helping.
Thank you.
Thanks.
Thanks for having me.
Okay, bye, guys.